Hello everyone, my name is Suresh Kumar. I want to give an introduction class for diode circuits in the subject called digital electronics. Diode is a device which works like a switch. The symbol of diode is as shown below. This terminal is called anode. This terminal is called cathode. Conduction will take place from anode to cathode. Since I said diode works like a switch, it has two conditions. One is on condition, another one is off condition. When diode is in on condition, it acts like a short circuit. That means from anode to cathode, a path will be appears. So conduction will takes place in on state. Whereas in the case of off, diode acts like a open circuit. That means there is no connection between anode and cathode. So conduction will not takes place in off state. But whether the diode is in on state or off state, it is decided by how we connected the power supply. That process is called biasing. So biasing, it is of two types. One is forward bias, another one is reverse bias. According to the textbook definition, forward bias means, suppose there is a diode like this and a battery like this. If this positive terminal is connected to anode and this negative terminal is connected to cathode, then this procedure is called forward bias. If we reverse the terminals, that means again diode is like this and battery is like this. If negative terminal is connected to anode and positive terminal is connected to cathode, then this procedure is called reverse bias. During forward bias, diode acts like on switch. In reverse bias, diode acts like off switch. But the problem is, in digital electronics, some situations will appear like this. Suppose if there is a diode and it has anode and cathode, and the power supply is connected such that both the terminals are in same polarity. That means either positive voltage or negative voltage. Both sides same polarity will be connected. In this case, we will confuse whether the diode is in forward bias or reverse bias. So the basic definition, which is correct only, but we can't judge the diode is in forward bias or reverse bias with the basic definition. So in the case of digital electronics, we have to improve the definition of forward bias. So I will consider the definition of forward bias like this. If anode terminal voltage is greater than cathode voltage, that means anode voltage, that means this voltage is greater than this voltage. I am not mentioning the polarity, no matter the polarity. If just anode voltage is greater than cathode voltage by the amount of cut-in voltage, then this condition is called forward bias. So the remaining conditions are same. That means in forward bias, diode acts like short circuit and conduction will takes place. Except this case, that means if anode voltage is greater than cathode voltage by the amount of cut-in voltage, then it is called forward bias. Otherwise, it is called as reverse bias. So we will check how this definition will be works in practical circuit. Suppose there is an example circuit here. In this circuit, we taken one diode and input Vi is given at anode and output V0 is taken at cathode, and two supplies plus 10 volts and minus 10 volts are connected by using two resistors at cathode, and this resistance value is 10 kilo ohm and this resistor value is 20 kilo ohm. And in the conditions they are given, V gamma, that means cut-in voltage, is equal to 0.7 volts and input is varying from minus 10 volts to plus 10 volts. The question is, what will be the output? Here there are some problems. First problem is input is not a fixed one. It is varying from minus 10 volts to plus 10 volts, and at the same time the type of waveform not mentioned here. That means whether the input is sine wave, square wave, triangular wave, that is not mentioned, but it is varying from minus 10 volts to plus 10 volts, and output is connected to two supplies, plus 10 volts and minus 10 volts. So here the problem is we can't judge by seeing the circuit whether the diode is in forward bias or reverse bias. The basic definition of forward bias and reverse bias are not applicable to here. So what we have to do? Suppose the voltage at cathode is, I mentioned as V suffix C. First we have to find this Vc. Why? Because this voltage is fixed one. Why? Because we connected two fixed voltages at this point, so the voltage at cathode is fixed. If we know the voltage at cathode, we can judge by comparing the input whether the diode is in forward bias or reverse bias. For that we have to use superposition theorem. Superposition theorem. Why we have to use superposition theorem? Why? Because it is a resistive network and we used more than one source, so we have to consider one by one. Suppose if I consider 10 volts, the resistive network will be like this: plus 10 volts, after that one resistor and its value is 10 kilo ohm, next the point at which I want to measure the voltage, and after that another resistor and its value is 20 kilo ohm, next minus 10 volts. But if I want to measure the response of 10 volts at this point, I have to consider the voltage at this terminal is 0 volts, and that is, it is considered as ground. So from 10 volts to 0 volts current will flow like this. So at this point some voltage will be developed. I have to calculate the voltage at this point. That is, first we have to take the product of supply voltage and resistance value which is connected between given point or required point and ground point. Ground is the reference point for measuring the any voltage. So first we have to take product of supply voltage and resistance value which is connected between required point and ground. So 10 into 20k divided by total resistance in the path, that is 10k plus 20k, which is equal to 10 into 20k by 30k. Here k will be cancelled, 0 will be cancelled, so simply it is 20 by 3 volts. So here this voltage I will consider as V1. So V1 is the voltage at the required point due to the supply voltage 10 volts. Now we have to consider minus 10 volts supply. At this time we have to neglect this 10 volts, so we have to place ground at this point. So I will consider ground here like this. This is 0 volts, and after that 10 kilo ohms, this is the required point, and after that 20 kilo ohms, next minus 10 volts. Here from 0 volts to 10 volts current will flow like this. Why? Because 0 is greater compared to minus 10 volts. But here again I have to consider the voltage at this point. Suppose it is denoted as V2. V2 equal to, again, product of supply voltage and the resistor which is connected between required point and ground point. See, always ground is the reference point. That's why we have to consider the resistor which is connected between ground and required point. So product of supply voltage is minus 10 volts into resistance value is 10 kilo ohm divided by total resistance value, that is 10 kilo ohm plus 20 kilo ohm. If I simplify this, I will get minus 10 into 10k divided by 30k. K cancel, 0 cancel. It is simply minus 10 by 3 volts. Actually, the actual voltage at this point we see is the algebraic sum of individual responses of this 10 volts and minus 10 volts. So I have to mention V suffix C equal to V1 plus V2, where V1 is 20 by 3 and V2 is minus 10 by 3. So if I simplify this, I will get 10 by 3, that is 3.33 volts. So this is the voltage at this point. So I can redraw this circuit like this. One diode. At anode I connected input. At cathode I can mention a supply voltage with value 3.33 volts, and at this point I am taking the output. So circuit will be simplified. Now I have to calculate the output waveform. For that I will consider input waveform as a sinusoidal waveform. See, this graph indicates input waveform. Actually in the question input waveform not mentioned, but I will consider for example only. So I will consider a sine wave like this. Okay, this peak value is 10 volts, this peak value is minus 10 volts. In the question or the circuit diagram, what happens here? At cathode we have 3.33 volts. We know the definition of forward bias. According to forward bias definition, if anode voltage is greater than by cathode voltage by the amount of cut-in voltage, here the cut-in voltage is 0.7 volts, V gamma is given. So when the input is greater than by comparing the summation of these two volts, then only this diode enters into forward bias. That means conduction will take place. Otherwise this diode enters into reverse bias. So the summation of 0.7 volts plus 3.33 volts is very important. Its value is 4.03 volts. This is the reference voltage we have to consider. So I will mention this reference voltage on this waveform like this. So 4.03 volts. The points at which this reference voltage touching the input waveform are very important. For showing the output waveform, I will draw a graph which is parallel to the input waveform. This is V out. I have to mention these important points on this graph also, like this. If we observe this waveform from this point to this point and from this point to this point, our input waveform is less than the reference value 4.03 volts. So that means anode voltage is less than compared to cathode voltage. So diode enters into reverse bias and acts like a open circuit. When this diode enters into open circuit, we can neglect the effect of input and output. So output is directly connected to this 3.33 volts. So output is constant and its value is 3.33 volts. That means from this point to this point and from this point to this point, diode enters into reverse bias and diode acts like open circuit. No conduction will takes place. So the output is fixed value and its value is 3.33 volts. Now from this point to this point, our input exceeds the reference voltage, that is 4.03 volts. That means anode voltage is greater than by cathode voltage by the amount of cut-in voltage. So diode enters into forward bias. That means this region indicates diode enters into forward bias and it is short circuited. Diode is short circuited. When diode is short circuited, what happens? If this path is short circuited, this input voltage will appear at the output. At that time, this 3.33 volts will not affect the output. Why? Because Vi dominates the 3.33 volts and we know that in parallel connection voltages are same. So this Vi will directly appear at V out. So output is directly equal to input. So output follows the input curve as it is. So this maximum value is 10 volts. So from this graph we can say that when input voltage is less than the reference voltage 4.03 volts, output is fixed and its value is 3.33 volts. Whenever the input voltage exceeds the reference voltage 4.03 volts, output follows the input as it is. Whatever the shape of waveform will appear in the output. So in this manner we can analyze the output of diode circuits. Thank you.